Chapter 3 is going to talk a lot about solving systems of equations. A solving system of equations happens when you have two equations, mostly linear is what we'll be playing with, and they're going to intersect at a point, typically. So first today we look at it graphically. Here's the three ways it can kind of look. I have two lines, the red one and the blue one, and they intersect at one point. This is the case for most lines. Now, every once in a while, by the way, we're going to talk about number of solutions with this, and when I talk about number of solutions, if they intersect exactly once, that means they have exactly one answer, or one solution. What becomes interesting is every once in a while you're going to get two lines, and it turns out they graph to be the exact same line, which means they have an infinite number of spots where the graph is the same. So then last but not least, every once in a while you're going to find out that they're parallel. No matter how far you extend them, they are never going to intersect. In this case, it will be no solution. So the first example, they're actually going to give us a graph, and we get to say where they intersect. So it says, let's see, y equals negative 2x plus 3. That's going to be the green line here. Then it asks for x minus 5. That's going to be the purple line here. So it looks like they cross exactly once. I know it's asking if it's consistent, inconsistent, independent, dependent. We're going to ignore that part, and I want you to tell me where they intersect. Because today, that's what you're going to be doing. Graphing two lines, tell me where they intersect. And it turns out this time it looks like, what, maybe 1.7 and negative... Ooh, that's kind of rough over there, isn't it? Let me try that again. 1.7 and negative... Wow, you guys, that should be 2.7 and negative 2 point, I don't know, like 3 maybe. Okay, that's basically what we're going to be doing. Let's try B for giggles. Negative 2x minus 5. Negative 2x minus 5 is the red line. Negative 2x plus 3 is the green line. It looks like they're parallel, so it would be no solution. So really what we'll spend most of our time doing today is not having the graph. We will have to graph it. And so here's the first example of that. It looks like I need to do plus 10. Let's go by twos. 2, 4, 6, 8, 10. So I can put a point here. And then since it's down 3 over 1, it would be 1, 2, 3 over 1. 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 My suggestion to you is to, at least for the first one, take it all the way across your paper. Don't do it just halfway. Do it all the way. You can go ahead and connect these with a nice straight line. Minus 2, so 1, 2, put a point. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And really, you only have to take this one as long as it takes for it to cross the other line. So it crossed right here, and that point was 1, 2, 3, up 1. What'll be interesting is sometimes they're not going to give it to you in y equals mx plus b form, slope-intercept form. You're going to want to write it. You're going to want to write it that way first. So, like for example, this top one, I'm probably going to subtract 2x from both sides, so that I have negative y is equal to negative 2x minus 1. And I'm going to divide everything by that negative 1 so that I have y equals 2x plus 1. If I graph that, there's my y-intercept, up 2 over 1, up 2 over 1. Backwards, down 2, left 1, down 2, left 1, down 2, left 1. Take that first line all the way across the graph. Great, now over here, looks like I'll probably subtract 4x from both sides. So that I have negative 2y equals negative 4x plus 6 if I divide by negative 2. 1, 2, 3. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Hold on a second. This looks like it has the same slope. And in fact, if I look here, 2x plus 1, 2x minus 3, that does appear to be the same slope. So the answer here is going to be no solution. An example of when you might use this is to find out when two events will happen at the same time. Sales is a big one that you'll see in this. Here we have some books. One person already has 35 pages. The other one's ahead at 85 pages. But the first guy reads faster, 20 pages a day. So eventually he's going to catch up and then read more pages, have more pages read than the other person. Another place you might see it is like cell phone companies is a big one. Of course, not quite as much anymore because there's so much unlimited. But I'm telling you guys, way back in the day, you only had like so many minutes on your phone plan or something. So if plan 1, you get the first 100 minutes a month free. Then after that, it's 10 cents a minute. The other plan is 200 minutes, and then after that, it's 5 cents per minute. If I know I'm not going to talk on the phone that much, the 10 cents per minute plan might be the plan for me because I know that I'm not even going to cross the 100 minutes. But if I spend a lot of time on the phone, I might want to go to the 200 one because eventually, as I have to pay 5 cents per minute, I will have definitely saved and caught up than I would of the other plan. So